Hey there.
Hello, can you hear me?
Yes, we can hear and see you very good.
Awesome.
So, Ingo, I'd like to use this opportunity and say thank you for staying with us throughout the whole conference. I think we've seen you every day now.
It's been a blast. I was missing the after conference drinks a little bit. I didn't really feel like it at 2 a.m., but
yeah, sure.
Another time.
Alrighty. So, Ingo, the stage is yours.
Cool. So there's share screen. Entire screen. There we go. All right. So I'll be talking about community data, which has been a bit of an obsession of mine over the last couple of years. There's just all this wonderful data that this community creates, and sometimes I get to use it in my job because part of what I do is product management and just making sure we're making sound decisions around where to put our efforts. But then also qualitative data, like thanks for filling out the community service that I'm putting out every year. But apart from analyzing all the data that's there, I think I've always found ways to make this a good excuse to play with new technologies. I think this is something from an internal dashboard that we have. This is showing you some stats from all core and supported modules, so 70-odd Silverstripe modules. There's various ways you can read this graph, glass half empty or half full, right? But I think what data can do when it's applied well is provide a bit of perspective, right? I mean, look at that growth. That's insane. Not the bugs, but just the activity, right? And there's one thing I wanted to point out that's worth celebrating, I think, that this year is the first year that we've closed more bugs than were created, right? So in this one, I'm a little bit more of a glass half full guy. This was a lot of work, and thank you if you've contributed to that with pull requests, with filing good bug reports. And a special shout out to the CMS squad here at the mothership in Wellington, who's been really doing the hard yards to prioritize the triage and fix bugs. So as you can see, open source is a huge undertaking. Like, look at those numbers, right? So we've built something great. Let's make sure it stays great. Today, I want to focus on this, which is all the events across all the community modules that were ever created in GitHub. So pink here is, I think, pull requests, and dark orange is issues. And there's going to be commits and comments and everything else, right? So quite a lot of data. This is encapsulating 360,000 individual data points. This is visualized with Google Data Studio, which I'm hoping to publish afterwards. So lots of juicy data, but actually what I want to focus on is this, and this is my activity. So it's quite humbling when you look at it on the same scale, right? Like, it's like, oh my God, there's a lot going on that exists outside of your control that you had no part in. So it's fantastic to see that difference here, right? But today I'm going to be a bit selfish, and I'm going to explore the community data with machine learning. And I have to warn you, I did get a little bit carried away with it, and I did ask Julian for a couple of extra minutes here. A couple of days ago, it's like, hang on, like I'm not doing anything in PHP or JavaScript, and the Silverstripe association is quite tenuous at best. But this is a talk about some shiny new stuff, and I think it's more about the journey of learning something new than it is necessarily about showing a lot of code. So if I'm zipping through that, then don't worry too much about that. So I managed to hit nearly all the buzzwords. I am working with big data. I am doing neural networks, and of course I wouldn't be here if I didn't find any way to get GraphQl in the picture as well, right? So I actually wanted to deploy it serverless as well, but the app got a little bit too big, so unfortunately I didn't hit all the buzzword bingo. But I think that's a pretty good gather to start off with. So what's the problem statement? Well, that, right? Like, we all have that, GitHub notifications, and there's just a lot of them, right? This is a screenshot of my inbox from a couple of days ago. GitHub actually does a reasonably good job at telling you what it thinks is important. You know, if you've been mentioned, if you've participated in a discussion earlier. There's already a lot of good ways. Like, I'm not going to get through the 793 things that it wants me to look at, but if you look at the stuff at the bottom, that's a pretty good start. But hey, can we do this better? So one thing is, when I submitted this talk, I had no idea if this was going to work, which is actually a great way to force yourself to learn something. You just say you're going to talk about it, and then you have to figure it out. Pro tip. So that's what we're working towards. It's the great GitHub issue machine learning experiment. You chuck in an issue URL or a pull request from a repository that I have participated in previously, and it'll tell you if you might be interested in that. So how do we do that? Well, the master plan is get some data with labels. That's what machines need to figure out how to train. I'm going to train a neural network, I'm going to create a prediction service, and in the end, I'm going to be a cybernetically enhanced open source maintainer. That is the plan, at least. Lots of shiny toys to play with. So the data set that I showed you before, that's stored in Google BigQuery. It's effectively GitHub pushing a daily backup, so to speak, from all of its events into BigQuery, which is a big data SQL store, effectively. FastAI is a Python framework for machine learning. Their slogan is making neural networks uncool again, which really resonated with me. So I haven't studied this stuff at uni. I don't have even a proper comp sci degree, and this really resonated with me in terms of just giving it a shot. Paperspace is basically a GPU in the cloud, because I don't have a big one on my machine, and it's quite easy to do that in the cloud now. And of course, Graphql and GitHub need to fit us somewhere in there somewhere as well. All right, so let's look at an issue, the anatomy of an issue, and figure out what kind of signals we could use to help such a prediction service. So you can look at the organization, Silverstripe in this case, the repository that the issue or pull request is in, if it is in an issue or pull request, and who's filed it. So it's a couple of parameters that I can start building my data set out of. If you dig a little bit deeper, you can look at how many characters are in the title, in the body, if the body is using Markdown, if I've been mentioned. So just some things where it's a little bit, I'm not exactly sure if there's a correlation, but it's the pack rat approach. You just get all the data that you can, you give it to the machine, see what happens. Digging a little bit deeper, if you look at the person submitting that, how much have they interacted with that repo before? How many issues have they opened? How many pull requests? How have I, because this is again a personalized recommendation engine, how much have I interacted with that particular repo? So those can all be inputs for a service. But machines can't really tell you anything without labels on data. So the labels in this case is the amount of interactions that I have demonstrated on an issue. For many, that is 0. I have not commented on them. In this case, I have commented a bit, and I have also closed the issue. So those are all, there's a fairly high interaction that I could use to calculate a score. Like issues like that, they trigger my interest. Just in a very brief sentence. Right, so concept is there. Now we need to get some data. This is the boring part of any data science. It's still just good old SQL and scripting and filtering data and dealing with messy stuff. So this is part of a BigQuery SQL query. There's actually probably another 3 screen pages above and below this. But yeah, that's what's required if you want to work with your own data. It is not your grandpa's SQL though. So this is a screenshot from the Bigquery Console, and you see at the bottom there the preview says, if I'm running this query, it's going to process 6.1 terabytes. That is effectively the size of the GitHub archive data set. And 1 terabyte costs $5 US. So when I hit that run button, it's going to bill me $30. And yes, I have messed that one up. Not with $30, but I have had $5 queries, was like, yeah, I've done it wrong, I need to run it again. So as you know, a SQL, high stakes SQL, I would call it. So now that we have some data, we can form an intuition about them. And this is where, this is pulling in 15,000 data rows. So this is not something you just open in a spreadsheet and kind of scroll around, right? You need to have a way to figure out what is actually in that data. So this is where these kind of plots come in. This is a box plot. At the top, you can see the distribution of the 3 things I identified for scoring. So there's quite a lot of outliers, which is all those dots. There's actually been one issue that apparently I've had more than 40,000 character comments on it. I don't know which one it is, but it must have been a really interesting one. So knowing that about the data, I can normalize that and kind of put it on the same scale so that it gives machines a better shot at actually learning from that distribution. So now that we have a bit of an intuition on the data, let's get into the interesting stuff and train some neural networks. So this is unfortunately not done with PHP. It's basically not present in the data science world. This is Python. But this is just an example of how well abstracted this is now, right? So you get some stuff from Bigquery. You create a thing called tabular pandas, which is basically a representation of the data table. You process it a little bit, you tell it what columns to use in which way, and that line 14, that is where the magic happens. Now it's going off and training it, and then you can do predictions. So in the real Python code that I'm going to share, there's a little bit more to it, but you can get quite far without lots of kind of fancy things like ReLU layers and things like that. So this has been super fun. All right, so if you look at that, so this is this little part in action where it's finding a learning rate, which you can then use to figure out how you want to train your model. And this, I'm just showing this not so much for the exact code, but because this is a Jupyter notebook and it's effectively an interactive programming environment that is non-linear. So this is actually me clicking Shift-Enter on a bunch of rows in sequence, and I can actually go back and run certain rows again, retaining the same state. It's been really mind-blowing when you're coming from a PHP world where you kind of deal with workers and CLI scripts. Super fun. This is the actual training in real time. This took, for 15,000 rows, this took 4 seconds. 16 gigabyte GPU. Not sure how much of that I've used, but yeah, it's pretty fast when you run this stuff in the cloud. This is now going off. Now that I have a trained model, I'm actually going off to GitHub and getting a data point it hasn't seen before, and just looking at the predictions for that, just to get an intuition for how well that model works. And it's flicking past a little bit, but it's effectively a score between 0 and 1. And in this case, it's a 0.1 interest score, for lack of a better word. Shout out to Graphql again. If you're looking at API design, you can't really go better than looking at the GitHub API. So they have a resource query endpoint where you can just chuck in any GitHub URL and query quite deeply nested data on the data set. I'm getting like contributions by year and things like that out of effectively a single query. It's quite crazy, how powerful GitHub made the API. So how did it go? 88% accuracy. I was like, holy shit, am I the master of machines? But of course, there's always a gotcha, right, when you're doing these things. So I looked a little bit more into the data, and if you look at the distribution, there is a lot more issues and pull requests that I have never interacted with, right? Guess what the number is? 88%. So effectively, what I built was a really fancy version of this. Like this would also be a prediction algorithm that would have an 88% accuracy in this case, because that would be all the zeros. So then I started questioning my entire life decisions and was like, okay, but how do I get out of this, right? But that's the thing, right? You need to get yourself in situations like that, because then when you start learning, you can't fake your way, you can't copy paste your way through this anymore. You actually need to understand what's happening. So there's been lots of trial and error getting to this point. And I think I learned a lot about, how neural networks work and what they're good at and what they're not good at. One thing they're not good at is cause and effect for humans. You can't easily see which features are important, which of the parameters are actually triggering it more. It's just a big black box. It's a whole bunch of numbers that are multiplied. And I was thinking, well, it's just multiplication. How does it multiply categories, right? They're just strings, and then you start looking into how it does that. So I just learned lots just by being forced to understand it. That led me to exploring alternative approaches. When I first talked with Sam about this idea, he was like, just use random forests. And of course, Sam's always right. So yeah, random forest has actually been around for 30 years, right? So this has been a fairly old school tech that's doing a lot of heavy duty work in real world applications. So he had a pretty good intuition with that. So the thing with this Python machine learning stuff is, I was mostly on the way to just switching from a neural network to a random forest, and then reading up about that and just getting the intuition for how that works. So that's an example from scikit-learn in the same Python notebook that I have on how to run a random forest classifier. You see, there's not a lot to it. There's much more to it when you actually want to interpret what it gets out of you, but the training is very similar. So one thing that I got from this approach is an intuition for which of the features are important. And kind of unsurprisingly, the creator of the issue is quite important. Like there's just lots of people that I interact with a lot. If I've been mentioned, yeah, that's a pretty good signature. But repository was a lot less of an indicator than I thought it would be. So there's a couple of interesting insights about how you know yourself and how how a machine thinks that you're predictable. So you can't really talk about machine learning without talking about bias, right? Because we, as programmers, have responsibility to get things right, and this stuff, treating it as a black box is quite dangerous. So I was starting to think of what am I actually doing here. One bias that I built into the data selection is I've looked at past interactions. I might have been interested in something 5 years ago. That doesn't necessarily predict I'm still interested in it, right? It's also disadvantaging new contributors. If I don't have a history with you, the machine's probably going to rank you down, and I probably will miss your tickets. So those were really good questions. It's like, yeah, the machine, they can't solve this for you. You still need to apply your judgment to this, right? Anyway, so after a lot of soul searching, I created a prediction service for this that you've seen the screenshot before. So if I'm opening this up, so I'm just going to get literally the newest issue that we have. So this is the Elvis tool I showed you yesterday. Can you see that on the screen? Like, let me know if you can't. And I will just chuck in the latest one because that's one it hasn't trained on, right? No, you're probably not interested in this. Negative score. Oh my. Okay. So you go a little bit further, and there's a couple of Graphql ones. So so it's like, which one? That one. Let's just take a Graphql one. It's like, okay, let's see. Graphql must be. I mean, Graphql is always tickling my fancy, right? Yep, you're quite interested in that. But the thing is, that's an issue that I filed myself. Yeah, I'm probably going to be interested in that, right? So that's the case I didn't consider. Here's an RFC from Sam. It was like, hey, come on, this ticks all the boxes. Like this surely must be going well. Yep, you might be interested in this. So it's kind of a little bit hit and miss, right? So if I'm going back to the slides, what I ended up with in some variations of this model, I got to 94% accuracy. But if you think that 88% of the scores are 0, effectively it's still only 50-50. So what I've created is effectively my own Marvin, if you know that Hitchhiker's Guide reference, where it's just like, you're probably not going to be interested in it. It doesn't matter, So one interesting side effect is I've actually undermined my own data. I was trying to take out the temporal scores of the data because I'm looking at a lot of new issues, right? They don't have any comment history. I can't take that into account. And in the way that I've done it, I've effectively canceled out all the other data in the model. So I've basically given my model 2 conflicting views of the same data point, which effectively randomized it. So that took me like quite a while to get my head around. But learned heaps while doing it. And I think that's probably what I want to leave you with here is like, in these new things, the journey is often more important than the destination, right? You have to allow yourself to fail. And you can't set your stakes too high for building something that has like real world application use. I was perfectly happy with building something that was only applicable to me, that only worked with my data, right? It's good enough. I learned a lot because I think a lot of these hobby projects tend to never get off the ground because people just want to build something that is basically a startup idea. And that's just setting the bar so high that you're just never going to start. So embrace failure, enjoy the journey. If anything, maybe it's taught me that I'm not as predictable as I thought, or I'm not as good as programming machines, either one of those. But I've definitely built up a little bit more of an intuition. I have a better sense of, is this a good machine learning problem now? Does it pass the sniff test, right? Machines, they're effectively, in the way that neural networks work is not too similar to our brains. They want to detect patterns, right? So if you look at the cloud, your brain will start to see things, right? It'll overfit. It'll try to fit these patterns, but it'll also see things that aren't there. And I think that's also something to realize, that machines will do that as well. They will find patterns where there are none if you're getting it wrong. So just to conclude, so actually before this, I had built something that was a little bit more rewarding, but also a lot easier, which was a classifier for detecting my dog. And that was simply because I have a lot of photos of my dog. And it's not only a classifier for my dog, but it'll distinguish it from other dogs of the same breed, which I showed friends photos of my dog, Otto, and some other dog of the same breed, and they weren't always able to tell. And this thing here got me to 90+% accuracy by just uploading some images effectively. So this is a super interesting space where a lot of what you get to do in a couple of lines of Python these days is effectively been the state of art 3 years ago, where it took a whole bunch of PhD students a year to get there. And now in 3 years, all of these best practices are codified in a framework like FastAI, and you can just use it. And you get this magic box that will just, find features and images for you. So this has been super fun to work with. Something quite different to web development, right? But I've really enjoyed the journey and the experimental nature of it. Cool. Thanks to the Noun project for all the amazing iconography and to Flickr Creative Commons for the nice cloud image. Cool. Man, I've rushed through this a lot quicker than I thought. Any questions about it?
Actually, you're right on time. Well done. Any questions for Ingo? Come on, guys. This time it's really your last chance because we won't see him tomorrow.
How do you prevent the algorithm from not becoming biased? Simon is asking that. Yeah, that's a big thing. It means you need to understand the data. You need to understand the process in which it evaluates that data. I've read about things like where one example that I read about today was they were trying to predict if grant applications were successful, and that was a computer science challenge. And they had a really high correlation. They were figuring it, they were saying with 95% accuracy, we can tell if the grant was successful. Turned out that the university was not filling out a lot of the data until a grant was approved. Then it got more data. And that was the starting data set for the machine learning competition, right? So because of that built-in data floor, you now have a model that way over fits into things that have already been approved, right? So this is all the way through from data collection to what the actual problem statement is. Bias will always creep in.
So Andy Smith is asking, do you think this is a good way to improve site search?
So I've probably actually used FastAI for the worst use case, which is tabular data. You can get a lot better results with things like natural language processing and collaborative filtering, both of which could help you with site search. It really depends on what you're trying to do. I think collaborative filtering is definitely an area, other people were interested in that search result. You might be as well, based on your past behavior. There is a lot of opportunity there.
Anything else, guys? We have time for one more question before we will be taking a 5-minute break to set all our Lightning Talk speakers up. Yeah, we've already addressed that question, but thanks, Martina. Okay, well then, Ingo, again, thanks a lot. Very cool talk, a little bit machine learning in the conference. Please have a look at the poll about machine learning. I love polls. So, Ingo, thanks a lot. Cheers.
Thanks, everyone.